Dr. Madhusudanan Bhaskaran sir, Professor, Department of CSE, Work Integrated Learning Program, BITS Pilani. So he is having 8 years of experience as a adjunct professor at various Anna University affiliated colleges, and now he is a guest faculty at BITS Pilani for their Work Integrated Learning Program, teaching data science. He has a professional with 25 years of experience in technical aspects of product development from the discovery and innovation stage of product launch. And also he have a good experience in handling cross-functional teams of 15 professionals with strong experience in design and development, program management, mentoring, and pre-sales. And also he is a part of 2-year-old EdTech startup TriniPi, focusing on building the 360-degree skills for success. He also have a strong theoretical background and application knowledge on emerging technologies, including artificial intelligence, machine learning, wireless sensor network, Internet of Things, and also he have mentored over 11,000 career professionals, teachers, and students. He have published 20 articles in Scopus Index and SAI journals in the last 10 years with a H index of 6. And his core competencies is product development lifecycle, new technology incubation, rationalize AI/ML, manage cross-functional teams, mentoring, and research. And his career highlights, he have rolled out artificial intelligence and machine learning solutions for EdTech, agri-tech, and greenhouse domains using wireless sensor network, image processing, and customized neural networks. And also he have developed and deployed embedded system-based solutions in the medical and precision agricultural domain. And he also lead the product team from incubation and deployed biometric solutions for clients, including Precision Informatic and Bharat Electronics Limited. He also have 20 research publications in high impact Scopus and SEI journals in the field of artificial intelligence and machine learning, data science, image processing, signal processing, and wireless sensor network, and also Internet of Things. And then he built the edX services company, germinating an idea based on proven research techniques to a business model using artificial intelligence with machine learning with a small team of 18 people involved in the market research for the business opportunity, planning, requirement, design, and prototyping and testing stages. And he also authored the personality career mapping based on extensive research and localization using Riaset and other tools. He also designed the interview template generation tool independently using artificial intelligence and machine learning with a high degree of supervised learning and design in patentability search pending stage. Also, he also led the department research and development and enabled funding through different agencies including AICT and DST. So he also provided academic solutions to engineering colleges, support in research proposals, handling conferences, and trained the trainers. Handled multiple workshops on research methodology, and also he have prepared academics and students for research proposal presentation. He also a member of board of studies and also governing council member. He have handled over 100 hands-on sessions in the areas of artificial intelligence and machine learning using Vega and MATLAB. So today we have before that he have completed his UG in Sri Jai Ramachandra College of Engineering, PG in M. Kumarasamy College of Engineering, and his doctorate degree in Anna University in the area of wireless sensor network with artificial intelligence. So today we have an eminent person. So I request the participants to utilize the sessions. So on behalf of Department of Computer Science Excel Engineering College, I would like to welcome our today's person, Dr. Madhusudanan Bhaskaran sir. Welcome you, sir.
Thank you, madam. Pretty long introduction. Okay. So no, I would like to have these sessions pretty interactive. So no, you are free to ask questions. Please answer questions. Let us make mistakes in this forum. When you make mistakes, you learn. No, that is my Ajay, no, that is my mantra. You make mistakes, you learn. Okay. And I think today I'm supposed to talk on big data algorithms. Okay.
Sir, sorry for the disturbance. Sir,
Yeah.
your voice is little bit loud, maybe little bit louder.
Okay. I'll increase my voice then. Is it better now?
Okay, sir.
Thank you. So, I would like to, this session, the next 2 hours, what we will try to focus is try to understand the data in big data. Okay. So when we require the foundations to be pretty strong, and no, that is what will help you in becoming successful for applying the right algorithm. Let me present my screen. Okay, so I hope you are able to see the screen now. You are able to see my screen? Anybody? Are you able to see my screen? Somebody can tell me.
Yes, sir. Yes, sir.
Yeah, thank you. Yeah, no, I think you need to be more interactive. As simple as this thing. My topic is, no, I'll start off with algorithms. I'll be getting into algorithms, but my entire focus today is for you all to understand what is data. Okay, that is extremely critical because you see big data. So the moment you see big data analytics, we are seeing one keyword, which is data. Let us try to understand data better. Okay, you can apply any algorithms only if you understand data, if you know what is data. If you are not able to do that, half the battle is lost. Okay, you make all the mistakes, it becomes a cascading effect. You, if the data is, no, the way you analyze the data is wrong, then it is going to have a cascading effect. Now the moment we talk of algorithms in big data, whatever, no, we might talk about various things, but now one key parameter that we are talking, we'll be looking at is the algorithms. And no other key words that I'm looking at is words like Python programming. Okay, so let me be very clear on certain things. Today, maybe I'll give you a couple of demonstration on Python also, but I would like to inform you, Python is just an engine. You give wrong input, it gives you wrong output. You give the correct input, it gives the correct input. Now, the black box, which is run using the Python, no, some algorithm is the black box, and you are invoking that algorithm will automatically be done using Python or one of its libraries, and that algorithm has to map with your data. If the algorithm does not map with your data, you are going to have problems. Now, you would have learned about a lot of classification algorithms in machine learning. I hope you have foundation in machine learning. You might be talking about decision tree algorithms. You might be talking of logistic regression algorithms. You might be talking of neural networks. But the $1,000,000 question is, where can I apply decision tree? Where can I apply neural network? Where should I apply, logistic regression? There are rules. If you are able to master these rules, you will be able to succeed in big data. And believe me, this is, you are not the only people who are struggling or may not understand. I am talking of people in the industry also. I'm talking of huge companies like Microsoft, Oracle. I mentor their managers, architects, and no, that is one challenge they find. No, the foundation is weak. So initially, the first 15-20 minutes, I'll be talking about the data in big data, the data. Okay, I would like you all to be interactive, raise questions. And, there is absolutely nothing called as having a wrong answers. We can learn by that also. Okay, when you're talking of data, a data can be of two types: continuous data or discrete data. Within discrete data, again, we can broadly classify into four areas. nominal or categorical data. The moment I talk nominal or categorical, I have a set of categories: male, female, true, false. Okay, Chennai, Erode, Coimbatore, Madurai. So I have data which is unordered. That means no, if I put Coimbatore first and then Chennai next, there is no problem. If I put Chennai next and Coimbatore, no, before that, I don't have a problem. There is no order in this. I can say male, female. So there is no harm in telling female, male, male, female, or female, male. Either way, it is okay. So there is no order. This is called as nominal data. Now, certain algorithms perform extremely well with nominal data. Anybody has bandwidth issues? I hope no, you're all not having bandwidth issues. There is no cutting in the line and all, right? There is no break. Okay. The second type of data that we look at is called as ordinal data. Now, ordinal data is a categorical data which has a rank. That means no, I can say something like this. If you go to Amazon and you rate a product, very poor, poor, average, good, very good. It can be anything. So it is called as a five-point Likert scale. I can have 7 points also. Extremely poor, very poor, poor, average, above average, good, very good, excellent. 7-point Likert scale. I can have a 10-point Likert scale. Absolutely not a problem. Okay. This has a rank because very poor is worse than poor. Poor is worse than average, or average is better than poor. This has a rank. The third type of data that you will see is called as the interval scale. In interval scale, you have uniform spacing between the variable component. So it can be age. Okay, I'm looking at height, weight, age. This can become interval data provided there is a uniform spacing between two variables. That means no, if I round off the age to the nearest integer, then I will be able to see the I'll be able to call it as a interval scale. Alternately, if it does not have scale, so I have 25.2 years, 25.4 years, or 50.2 kilos, 50.5 kilos, then it becomes a continuous data. Continuous data can be converted into interval data if possible. There are ways to do that, which I'll discuss. The final type of variable that we'll be seeing is called as the ratio scale. Ratio scale is an interval scale, but there is one additional point that we need to understand. Ratio scale has a true zero. Ratio scale has a true zero. So I'll give you one simple example of true zero. Now let us say in my classroom of 50 people, I find the height of each person. Okay. When I find the height of each person, it can be whatever it is, 4 feet 5 inches, 4 feet 9 inches, or 6 feet 2 inches, whatever it is. One thing that comes to my mind immediately is the height cannot be zero. So this is a classic example where your height is a interval scale and not a ratio scale. Okay. So we require absolute zero. I'll give you one more example. If you are talking about temperature, 0 degree centigrade, 0 is not the true scale, true zero. In Celsius, 0 does not mean the true zero. Okay, the true zero is measured in Kelvin. So if I'm talking of temperature measured in Celsius, then it is an interval scale. But if I have the true zero, then it becomes the ratio scale. Am I clear here? Okay. So no, I am just trying to put it across in such a way that you'll be able to understand the importance or the sequence at which the data occurs. So no, each data is something which is one step above which has a unique characteristic compared to the other data. So if you take the nominal data, here there is no ranking at all. Okay. There is absolutely no ranking. Male, female, female, male, no harm at all. Ordinal data has ranking. Interval data can also be considered as ordinal data in certain scenarios. As people who are no many of you who might be doing your PhDs, when you're analyzing the data, then you might be forced to convert the interval data to ordinal data. Will state whenever the distribution is not normal or it is non-normal, then no, a interval data can also be considered as ordinal data. There will be a overlap ratio. So this is what we are talking about. Now when we look at this, when we look at the data, the first and foremost thing that we need to understand, or most of the algorithms understand, is it follows a normal distribution. When I state it follows a normal distribution, that means my data will be something like this. If I normalize the data, maybe using z-score, my mean will be 0. Then I have my 1 SD, minus 1 standard deviation, minus 2 standard deviation, minus 3 standard deviation. This is ideally what you see in textbooks. But today what we'll do is, I will take up some real-time examples from very high indexed ACI journals. We were on latest experiments. I'll be talking about COVID experiments. I'll be showing you how data gets impacted and know what theoretically you learn and what goes practically. There is a huge gap. So the primary challenge is, if you do not have a normal distribution, you need to do lot of data manipulation, data handling, so that your system can analyze it correctly. So before getting into, because no, whether it is big data or small data, okay, small data, let me call it as machine learning. Okay, the technology, the underlying technology, the process to process the data changes, but fundamentally the data remains the same. Whether it is 10,000 or 1 lakh or 10 million, 100 crores, it really does not matter. The fundamentals remain the same. You need to understand the type of data. You need to understand and take it forward. So when we're talking about data, we need to do something called as descriptive statistics before talking of an algorithm. Okay, so when we talk of descriptive statistics, we immediately talk of mean, median, mode, right? Standard deviation. Of course, there is something called as range, quartiles. Then you have skewness, kurtosis. I will not delve into mean, median, mode. I think that you should be able to understand and take it forward very easily. But maybe I can ask you a simple question. If I have a nominal data, what is the descriptive statistics that I will apply, that I need to apply? If it is a nominal data, I should apply some descriptive statistics, mean, median, mode. Which is the correct thing? Should I apply mean? Should I apply median? Should I apply mode? Anybody who wants to venture?
So median.
Median. I will not say median. Can you justify it? See, look into the foundation and try to say whether it is median or is it something else. I'll come back to median, where why it is useful and where it has to be used.
Like you said.
No, but here there is no center value, right? There is absolutely no center value, because I am talking, let us say the nominal data is male and female. Where is the center value? I might have 40 males, 80 females. In this case, what is the, I am looking at the 40 male, 80 females is nothing but the frequency. Mode is the data with the highest frequency. So we need to use mode. Got it?
Okay.
Now, let us go to the next example of ordinal data. If it is ordinal data, will you use mean, median, mode? I want others also to answer. Make mistakes, you learn. If it is ordinal data, again, mode is pretty useful. Median can be used to a certain extent. Not every time, but again, mode is a good a data point to take it forward. When it comes to interval data, then what is it we use? We can use mean. Can somebody tell me when should I use mean and when should I use median? All this, whatever I'm talking in today's example, you will see. And I have taken the example from a SCI paper from Nature. Nature is the journal in which Nobel laureates publish. Okay, so I have taken up such a case study so that you can understand how really big data. So if it is an interval data, what is the type of statistical analysis will you do? Mean, median, or mode? Anyone else? I can use mean, I can use median. Now, when should I use mean, when should I use median becomes a big challenge. Okay, so when you talk about data, we are talking of outlier, right? So let us say I am talking of the marks scored in the class. Okay, you can understand, since you are all teachers, you'll be able to relate it very easily. Let us say the marks scored by 5 students are 20, 25, 30, 30, 40. So I have 5 students. Now if I look into the mean of this, you can say no, if you go and present it to the management, you can give the average score 70, 100, 120, 145. So let me also make this 25 so that no calculation becomes easy. 70, 100, 150. 150 divided by 5 is 30. So can I very confidently tell the students have scored an average of 30 marks, which is excellent. Okay, it meets, if you look into the data, the standard deviation, measure the standard deviation, you are not finding any, the deviation is perfect and no, there is no harm. But let us look at a scenario like this. If I had measured mode also, I would have got, what is it I would have got? I would have got something no about 30 only. Maybe 32. If I maybe even if I average, I would have got it as 30. So here the mean is equal to the median. Now look at another scenario. There are 5 students in your class. You're taking an exam. You're conducting a test. The marks scored is 10, 15, 20, 10 again, then 90. Okay. Now if I try to measure the mean here, 90 plus 10 is 100, 120, 130. Okay, for convenience I'll also make this as 20 marks. That is 150 marks divided by 5, which is 30. Here my mean is 30. Does it mean the whole class has scored about 30 marks? No. Correct. Most of the students have failed the test, whereas when you do the average, it shows as 30. Why? Because of this value. Now in big data analytics, one of the key components that we need to really worry about is this an outlier? I don't know. But no, this is the case where mean will help me. I can put it in arrange it in ascending or descending order. 10, 10, 20, 20, 90. The center value is 20. So no, I can confidently say the median is 20, which is very much true. If you go to the if you look into the analysis of the class marks, then you'll say no, okay, most of them have scored 20 marks. Maybe one person has scored 90 who is really intelligent, in which case 90 is true. Or okay, there must have been a mistake where the teacher, instead of putting it as 10, might have put it as 90 unknowingly. So if it is put as 90 unknowingly, then this becomes an outlier. Got it? So why this is important? Your algorithms are highly dependent on it. In the first case, when I plotted it, I would have got a beautiful normal distribution. But whereas here, when I plot it, I would have got a distribution which is like this. Because my 90 marks is here, I have my 20 here, I have my 10 here, 0. In real life, this is the type of data you'll see. Unfortunately, whenever you're working with data sets from textbook, most of them will focus on a normal distribution. But here you see, with 5 data, I'm able to show you non-normal distribution. So whatever techniques you use, whatever algorithms you use, it is going to be a challenge handling this data. You need to handle it holistically. You need to select the algorithm holistically. If I try to use a logistic regression algorithm here, it will fail miserably in predicting the scores of students in the class. It will fail miserably. That is what you need to understand, because in Python all I need to do is call LR, logistic this thing, regression, DT for decision tree. All I need to call, I give the data, it will process and give me an output. But you saw the mistake here. Simple descriptive statistics. I'm not even talking about machine learning. Here this is a normal data, this is a non-normal data, and whether to find it is non-normal, you have techniques. Okay, other than mean median mode might give you a very brief idea about the data, but then you would have read about standard deviation, but we need to go further than that and look at two more components, which are the kurtosis and skewness. Extremely important for the Python demo session that I'm going to give it to you. Then we have something called as range. Range is the value between the largest and the smallest. That means if I take the marks scored in the classroom, if for the first scenario where the marks scored was 10, 10, 20, 20, 30, the range is 30 minus 10. In the second scenario where the student had scored 90, the range becomes 90 minus 10, which is equal to 80. This again becomes a very good indicator to understand how the data is spread, which is extremely important. Okay, spreading of this data can be used for transforming your data or revisiting the data before you select the algorithm. Of course, you have the standard deviation and the variance. Straightforward. Range is highest value minus lowest value. I'll not get into that. Standard deviation, summation of x minus x bar whole squared. X bar is nothing but the mean value. So since I've used x bar, it means it is a sample data. If I had used mu, then it would have been a population data. So again, that becomes extremely important when you are using your machine learning algorithm in big data. Are you using the entire population or are you using a sample? If it is, if it had been a sample, if it had been a population, this would have become mu, and this will not have occurred. It will be only square root of summation of x minus mu whole square divided by n, where n is the number of samples. Typically, you can just hold on. Class call right. Okay, right. Sorry. This talks about the standard deviation. Now we all learn about standard deviation. We learn about mean, median, mode. But if you want to use it in your data analytics, it is extremely critical for you to understand or visualize standard deviation. In the mean, I can visualize. I have a group of students, center value, I can visualize mean. But visualizing standard deviation is something which you need to understand. Visualizing range is something which you need to understand, so that it becomes very easy when you take it forward. So when I have data, I can do a histogram of it. I can do a histogram of the data. So what do you mean by histogram? I might be having continuous data, or I might have a large number of discrete interval data. I might have a large number of ratio data, in which case I can form a histogram. So what is an histogram? Histogram is something where I bin the values. So coming back to your classroom example, I can say all the students who have scored between 0 to 10, 11 to 20. Okay, in textbooks or many of your Python, where it will always show as 0 to 10. Okay, then it will show 10 to 20. What this means is it is actually 0 to 9.999, and here it starts from 20 to 19.999. Okay, but no, here for the sake of clarity, I'll show it as 11 to 20, 21 to 30. I put the number of occurrence. So no, 0 to 10, somebody might have about 10 students would have scored. 0 to 20, about 20 students might have scored. 21 to 30, 11 to 20, 20 30, 20 students. 10 to 11, 21 to 30, maybe 40 students. I can plot it. Okay, and when I plot it, I get and I smoothen the curve. This becomes a normal distribution, but in real life it is not a normal distribution. As if you take this class in mark scenario itself, you will see a huge difference, because maybe I have somebody who is scoring 90 here, you have a lot of students who are scoring 70, a lot of students who are scoring 30, and on an average you have a lot of students who are scoring 50. This is how the curve will be. But if the class is very poor, then I might get something like this. Here, number of students who are scoring 70 will be very less. So my graph will be something like this. That means I am not going to get a normal graph. Lot of data is on the left hand side, which is very less marks scored. On the right hand side, the more marks are is not being scored, or it can be the other way around. All the students in the class are very intelligent. So what happens is, they might, number of students who have scored 10 20 will be very less, but whereas who have scored over 90 will be more, right? So this again is a skewness. If you can understand this data, then it becomes extremely easy for you all to select the right technique. Because today we all talk of deep learning networks, convolutional neural networks, but if you do not understand the data, you are going to get a lot of problems. So another important parameter that you look at is the quartiles. Quartile is nothing but the n plus 1/4 by 4 is the first quartile. It is also called as Q1. That means, why is this important to me? I have my normal distribution. This is Q2. This is Q1. Q1 is nothing but the 25% of the data. Starting from the 25%, it becomes Q1. Then I have Q3. Q3 is the 75th percentile or the 75th quartile of the data. So generally, when we talk about data in analytics, most of the data lies between Q3 to Q1. That is from the 25th value to the 75th value. That means, still understanding it better in a class of, if a class of 100 students have taken a test, the scores will lie between 25 to 75 or whatever. It can be a class of 500 students, and if the marks are, if they take an exam, you will see most of the scores between 25 to 75, and you will see almost 95% of the scores are 98.7% of the scores which lies between the 5th percentile to the 95th percentile. That means if I have 1000 records, only 5% of the records will fall in this area, and another 5% of the records will fall in this area. 5th to 95th can also be called as confidence interval. That means I'm trying to handle all the data in this range. Only if the data is highly skewed, or if the data has issues, you need to see whether this has to be eliminated or some other method of data manipulation done, so that my data becomes normal distribution. Got it? So you can see here that Q2 is nothing but the median. Q2 is nothing but the median. Now, if you do simple analysis, Q2 minus Q1 and Q3 minus Q2, if I subtract and get, I'll be getting two values, correct? Can we infer anything from this? If I measure Q2 minus Q1 and Q3 minus Q2, that can tell me the thickness of the positive side of the normal distribution and the negative side of the distribution. If they are similar, we can very confidently state that it is a normal distribution. Another way to find normal distribution. Okay, So the formula for the confidence interval is x bar plus z of s by square root of n. S is the standard deviation, n is the number of variables, and number of items in the variable, z is the z-score transformation. Okay, so maybe you would have learnt about mean, median, mode, standard deviation. We saw quartiles. I'll also talk how to visualize data using standard deviation and mean or median. Okay, so I was talking about the normal distribution, but here is a scenario where the students have got very low marks. No, x-axis is marks, y-axis is the number of students. We see that a lot of students have got low marks. Such a case is called as positive skewness. Positive because the body is on the positive side, and the tail is after the body. This is called as the tail, this is called as the body. So here I'm seeing that a lot of students have scored very less marks and very few students have scored very good marks. The other scenario is the negative skewness, where most of the students have scored very high marks and I have very few students who have scored very less marks. How will I measure the skewness? 3 multiplied by mean minus median divided by standard deviation. 3 multiplied by mean minus median by standard deviation. If you are able to understand this, this becomes one very, very important process for the entire data analytics. If we fail it here at this stage, if you are failing, you can be sure that you are failing on the entire research front. Another important parameter which is extremely useful to make a judgment whether it is noise or whether it is a unique data. That will be the next challenge that which we need to really try understand and take it forward. Okay, so the next, that is called as kurtosis. Let me. Okay, now what does kurtosis try to tell me? Kurtosis tries to tell me how heavy my tails are. What is a tail? This component is called as a tail. When I say a tail is heavy, it means there are lot of values which are outside the boundary or near the border of the boundary. If it is a normal distribution, we call it as mesokurtic, and the kurtosis value will be 3. If there is very less number of data in the tail, it is called as platykurtic. If there are lot of data in the tails, it is called as leptokurtic. Okay. If the kurtosis value is less than -1, I'll again I forgot to give you certain details. How will this skewness help me? If the skewness value is between -1 to +1, I can consider it as a normal distribution for all my analysis. Because the moment we talk of algorithm engineering, we talk about parametric tests and non-parametric tests. When I'm talking of parametric test, I need to make assumptions, and one of the standard assumptions that we do is, we talk about normality of the data. Whether the data is, whether the variables are multicollinear, whether there is heteroscedasticity. So these are some of the parameters that we really need to understand. Maybe the other terms I'll explain as we move forward. But here, as a thumb rule, if it is between -1 to +1, the skewness value, when you use the mean minus median divided by standard deviation, if the value you get is -1 to +1, then we can say it is a normal distribution. You can assume it as a normal distribution and apply any of your algorithms. If the value is greater than less than -1 and or greater than 1, then I need to assume it as non-normal distribution. I'll assume it as non-normal distribution. Whatever you have studied in basic machine learning, you would have studied, Pearson's correlation, you would have studied Spearman's correlation. Now, Pearson's correlation is ideal for interval or ratio data when the data is normal. Spearman correlation is good for non-normal data. Okay, or it can be used on ordinal data. So if the same thing I want to find the correlation between two nominal or categorical data, then I need to talk about chi-square test, right? But chi-square test, we are not talking of the data distribution. Here skewness becomes very important for interval / ratio data. If it is going to be greater than -1 or no greater than +1, less than -1 or greater than +1, I have a problem. This is where you need to clean the data. You talk about handling the missing value and things like that. Everything is fine. But no, when you're working real time, you need to take decisions here. So the same applies to kurtosis also. If my data is platykurtic, that means I have lot of outlier, very few outliers in the extremes. I can happily eliminate. I can take a decision to eliminate the data if required, so that the platykurtic can become mesokurtic, so that I get my ideal normal distribution. But what happens if the data is leptokurtic? I have a skewness value of 10, 12. I have a severe problem. I need to work on the data, or I need to understand or select algorithms which can handle this. So now if you're talking of leptokurtic data with a lot of outliers, nothing to worry, my decision tree algorithm will work pretty well. Okay. So now mesokurtic, leptokurtic, platykurtic, you can just have a look at it. Any questions till now? I'll take questions. I'll give you 1 minute. I can take questions. If you have any questions, please ask. Anybody has questions? Are you finding difficulty in understanding? I'm trying to go very simple, but at the same time, data that is extremely important, because I am also going to show you how to run this in Python. How to do that? It is very simple, but you cannot find the mean median mode in Python just by calling the description function. It will give you the mean median mode for categorical values also. So any questions before I move? Nobody has questions? Anyone has questions? Okay, I am assuming that you have all understood whatever I am trying to tell. So let me proceed, and maybe we'll after 10 minutes we'll try to again take a question scenario. Okay. So we were talking about, let me go so that we're talking about different types of kurtosis: mesokurtic, leptokurtic, platykurtic. Now, let me also try to understand how my normal distribution works. Okay, let me also try to understand how my normal distribution works. This is the data that I have with me. This is a typical normal distribution. Here, if you see, I am seeing mean. Here, the data is normalized. Maybe I have done a z-score normalization. I have done a z-score normalization. So my mean is going to be 0. Ideally, before applying any machine learning technique on the continuous or interval data or the ratio data, if you are not able to understand this, you will not be able to select the correct algorithm at all. Maybe you will be running around you'll be running around trying to use force brute method. What is force brute method? You will use the Python program, this thing. You will first call the Navy Bayes algorithm. You see the outcome is poor. You call the k nearest neighbor algorithm. You see the outcome is poor. You come to decision tree algorithm. You see there is an improvement. You try to use a neural network algorithm. You see the outcome is poor. You select a support vector machine. You see a certain good output. Then you take the data and you want to publish it. No. That is a classic case where you are overfitting the data. What do you mean by overfitting? Anybody can answer? That is a classic case of overfitting the data. Overfitting is the process wherein your algorithm will perform extremely well in the training data, but very poorly in the test data. Overfitting will highly occur. Okay, now let us try to understand what this means. I am seeing the mean, I am seeing plus 1 SD minus 1 SD. What does it actually mean? Let me take it forward. I have this data with me. I'll take an example. I have some 100 student marks. The mean is 50. The mean is 50. The standard deviation is 10. Let us try to understand what is standard deviation. Okay, so we'll try to visualize standard deviation. Now, here I normalize the data, so the 50 lies here. Plus 1 SD means 50 plus 1. This is my mean. 50 plus 10 equals 1 SD. 50 minus 10 equals minus 1 SD. 50 plus 10 is 60 marks. 50 minus 10 is 40 marks. So what I'm trying to tell is, in a class of 100 students who have taken the marks with the average of, with a mean value of 40 or 50 and standard deviation of 10, I can say 68.3% of the students have scored in the range of 40 to 60. That means in a class of 100 students, about 70 students have scored between 40 to 60. When I do minus 2 SD and plus 2 SD, 50 plus 20, 50 minus 20. So I have 70 and 30. That means I can say 95% of the students have scored between 30 and 70. 99.7% of the students have scored between, or no, almost 90, almost all the students have scored between 30 and 70. If I use minus 3 SD and plus 3 SD, that means I can very clearly state 20 to 80. I can say almost all the students, here it is 95, sorry, it is 95.5%, 95 students. Whereas when I look at minus 3 SD to plus 3 SD, I can say almost all the students have scored between 20 to 80 marks. Now, you might ask the question, what happens if the students have scored 90 marks, 92 marks? If the data had showed me students with 90 marks, 85 marks, 95 marks, that the standard deviation would have been higher. Maybe I would have got a standard deviation of 15. In which case, that data also will get selected. If your data follows something like this, then you can be pretty confident that you have a very good amount of, decent amount of data which can be used in algorithms. If you don't have that, we do have a challenge. Okay. So any question in understanding skewness, kurtosis, normal distribution? Why so silent? Students at least are more talkative. Why are you so silent? Anybody, any questions? You can either raise your hands, you can ask the question, type the question in the chat window. Anybody has questions?
Sir, so whether skewness and the kurtosis is to apply for all the data sets, or on what basis we can take it, sir?
Sorry, Tirunakar, can you repeat it?
Yes, sir. Skewness and currencies is need to apply for all the data sets, or how able to classify that for which data sets I need to apply this skewness, for which data set I need to apply skewness, any.
Sorry. I think I had a small problem with my headphone. One second. I'll just reduce it. Yeah, can you repeat the question?
Yes, sir. On what basis we can apply the courtesies and the skewness to the particular data set, sir?
On the data. Okay. See, you can apply skewness and currencies to understand whether the data is normal or non-normal. There are two things I can do. I have this data here, what you are seeing in the screen. If I measure the skewness here, it will be 0 because no mean equals 0. So I can, it's a perfect normal curve. But if I get a skewness of -2 or -5 or +2 or +5, if I get -2 or -5, then what I know is I know that there are outliers which are on the which are very large numbers. But if I get, let us say, +3, +4, then I know that there are outliers which are extremely small numbers. So I get an opportunity to handle the outliers. Got it? So I can handle the outliers based on the skewness. And if there is going to be curtosis, if the curtosis is very high, positively, high positive curtosis, I can know that I need to do an analysis before applying my classification algorithm to see whether I have outliers. So I need to take as a data scientist, I need to take a holistic view and select whether it is an outlier or not an outlier. Okay, so I need to make a decision. Now, if I don't take this decision and pass it on to my Python programming or no my black box which contains my algorithm, it is going to give me extremely wrong answers. The output is going to be poor. You might get some good solution, but unfortunately there's a good chance it could be overfitting of data. Okay, so selecting of algorithms, if you are not able to do descriptive statistics, then you are lost. You need to take up the big data, analyze it. So that is the first thing that you need to do. Okay, the second that you need to really do is see whether they are correlated, whether two variables are correlated. Now, when I'm talking about correlation in Python or no any data analytics, you just use a function called as CFS. Okay, so I use the function CFS or which is called as correlation based feature selection, or I can also use a Python program, Python language, Python tool. No, maybe I use the pandas library and I say COER. COER gives me the correlation. But as a teacher, as a researcher, you need to understand why it is working, how it is working. Okay, because anywhere and everywhere you talk, either in the industry or in research, we talk about only one thing in big data analytics. We talk of hyperparameter tuning. That means, what does it say? Yeah, we do have TensorFlow. We do have Python. Within that, you have very strong libraries like TensorFlow. You have no Hadoop framework. You can do a lot of work there. My challenge is not on that, but my challenge is how do I manage the data, because I give wrong input, it is going to give me wrong output. Okay, what I'll do now is I'll try, I think I want you all to be slightly more opening up. If you open up, it will be very nice. You will learn a lot, at least because these are all foundations. Okay, I'll share you one Excel sheet. Are you seeing an Excel sheet here? Are you able to see an Excel sheet?
Yes, sir.
Yeah, thank you. See, this is nothing but a very simple data set. Okay, it is available in the Kaggle database repository. So now if you are trying to do research and you want to validate your algorithm, Kaggle is a very good place to start because you have a lot of data there. So your data might be unique, but no, those are all data which are well tested, where we have done a lot of work to understand, and we raise questions to the authors, we get something which is pretty good. Okay, this is from the heart data set. Okay, when I'm talking about the heart data set, what this data set tries to do is it tries to classify a person either as male or whether he has a heart attack, or there is a probability of getting a heart attack, or he will not get heart attack. That is very simple. Given a set of independent parameters, I am going to find out the class label where 0 indicates it is not a heart attack and 1 indicates it is an heart attack. Okay, so very straightforward. You would have seen this, you would have worked on this, maybe you would have used R, you would have used Vika, you would have used Python programming, Python, whatever logic you would have used. But no, the $1 million question is whether have you analyzed the data, have you understood the data? Okay, so if you look in the first column, we have something called as age. We have something called as age in years. I'll just show you the data. You see that the minimum age is 29 and the maximum age is 77. So is this categorical data, ordinal data, interval data, or ratio data? Somebody can answer. What is this data type? Categorical, ordinal,
Interval data, sir.
interval data. Excellent. It is an interval data. Okay. Now let us look at the second parameter, chest pain. Look into the headings: definite angina, not angina, probable not angina. Tell me, what is this type of data?
Categorical, sir. Binary categorical.
Binary categorical. Okay. Anybody wants to challenge it? You are right. No, but let us also see whether somebody can challenge it. Is it binary categorical? Karpaga Priya, is it binary categorical?
Sir, actually, it is a categorical one. Whether we have two options, that is yes or no, where we can have
Yes.
0 or 1. So I have given
No.
that binary categorical, sir.
Here you have 4 values, right? So it is not a binary
Yes, sir.
categorical; it's a categorical value. But
Okay, sir. Okay, sir.
can somebody tell why this is not ordinal data? This can be a good case. No, chest pain. That means can it be ordinal data? It is not ordinal data. Reason being very simple. I cannot rank it. So I have 4 components here. That is why I said it is not a binary categorical. Definite angina, not angina, probable anginas. That means though we talk of chest pain, the doctor is taking a decision. Okay. So I have my resting BP, which again is an interval data. I have my serum cholesterol, which again is a interval data, because I see the smallest value as 126, largest value as 564. Then I have my fasting blood sugar. Okay. Now I have a simple question. I want to do data transformation. If I want to categorize the age into a ordinal data, how will I do it? If I want to change age into an ordinal data, what is it I should do? Data transformation. Any people working on machine learning? I see something in the chat. Anybody can comment, how do I convert this into a ordinal data? I might require, my work might require converting to ordinal data, which I'll explain when I'm getting into the algorithms part of it. Can somebody tell me ordinal data? How will I convert it? This is where your machine may not help you. May help you, you have tools, but they are not highly accurate. That is where, as a domain knowledge expert, you need to take the call. As a researcher, you need to take the call. Okay, so how will you convert this into an ordinal data? I'll give you a simple example. I'm looking at age. Okay, 29 is the smallest, 77 is the largest. Can I convert 29 to 40 as middle age? Can I convert 29 to 40 as middle age? Then 41 to say 50 as senior, 51 to 60 as very senior, greater than 61, greater than or equal to 61 as old. Maybe I can have very old category, whatever it is. But I am creating multiple categories. The process of creating multiple categories, and if there is a ranking to it, it becomes automatically an ordinal data. Okay, so can we take the same example with respect to fasting blood sugar? Okay, I want to convert this into two scenarios. The first scenario is I want to convert that into a categorical data, a ordinal data. What is the solution? What is the solution for categorical data? How will I convert blood sugar to categorical data? Karpaga Priya, Tiruvanakarsu. How will I convert? I have my fasting blood sugar. I want you to convert that into, I want you to convert that into either one categorical data, second ordinal data.
So by arranging the levels of sugar level like low or mid, high, very high.
Okay.
The same thing you can how you define for
That is for ordinal data. What about categorical data? What about categorical? How do I convert that into categorical data? Believe me, okay. For people
Based on their age, we can go with the height, estimation of height like that in that range, sir. Cholesterol level, the
cholesterol,
sugar level.
yeah, okay. Sugar level, okay. What will you tell? That is what Tirunakarsu said. He was talking of categorical, no ordinal data. No diabetes, borderline diabetes, okay, diabetes, unmanageable diabetes. That is what he was trying to tell.
Yes,
Okay.
sir.
So, but I want to convert this into categorical data. How will I do that? What is categorical data? True, false is a classic example of categorical data. This is where you can talk about non-diabetic, diabetic. Correct? The question, if I want to convert that into a categorical data, I could have converted that as non-diabetic and diabetic. Simple. It becomes no categorical data. There are only two categories. But if I say non-diabetic, pre-diabetic, diabetic, uncontrolled diabetic, then it becomes a ranking. So it becomes automatically ordinal data. Okay, this is what you need to understand. As long as you're able to do the basics, migrating from your current job levels to the industry is absolutely not difficult. I do see lot of teachers, professors who have gone back to the industry. They have been able to go back to the industry, and it is extremely easy because you have very strong foundation in the subject. The theoretical knowledge is extremely important. It is not the programming knowledge. Okay, it is the theoretical knowledge and how to use the theoretical knowledge and derive outcome from it. Now, if you are seeing a normal distribution graph, which I was showing you, if you are able to analyze it, half the battle is won. It is not about programming at all. I am seeing a lot of people who are migrating. Some of my mentees were, people I'm training in the industry. They do not have the teaching background, or they do not have the background on understanding the fundamentals, the basics. That's where they struggle. But where else, as teachers, you basically have the foundation, but the difficulty you have is applying it. If you are able to apply it, there is a huge opening for data scientists across India. A lot of hiring is happening because I mentor to the WELP in BITS Pilani. I also teach, mentor IIIT B industry professionals. This is where we see that a lot of people who are into software are able to get into data science very easily. But again, it does not focus. Programming alone is not important. The domain knowledge becomes extremely important, especially people who are working in image processing, and something, people who are working in opinion mining, sentiment analysis, unstructured data, people who are working in natural language processing. So if you're doing your PhD in that area, you will find that there is a huge demand for such people in the industry. Okay, so now let me continue. Then I have exercise induced angina 1 equals yes, which again tells me that it is a categorical data. Anemia, it tells me it is a categorical data because it is only 0 or 1. Now please understand, some algorithms may not be able to take categorical values which are non-numerical. Here, exercise induced angina, I could have put yes, no. Instead of yes, no, we have changed it to 0, 1 because maybe my algorithm is not capable of handling non-numerical values. In that case, what will you do for the gender? What will you do for the gender? How will you transform it so that my algorithm can understand?
The same 0 for male and 1 for female.
Yeah, you can put it either way because during the training process, it will automatically adapt 0 for male, 1 for female, or 1 for male, 0 for female. Absolutely not a problem. Then there is something called as level of the CPK enzyme with values between 24 to 922. Percentage of blood leaving at the heart at each this thing. And now what happens? Serum, fasting blood sugar, maximum heart rate. If you take these three components, are they interval data or ratio data? Are they interval data or ratio data? Should I call it as interval ratio? This is where you really need to think out of the box or think logically. Is it interval data or blood sugar is 0? Cholesterol is 0. In that case, it will become ratio data. But here, can we have cholesterol as 0? Blood sugar as 0? No. Right? Since it is not there, it is not possible, it becomes an interval data and not a ratio data. Got it? So level of CPK here, it's a controversial question, 24 to 922. So is this an interval data or is it continuous data?
Continuous data, sir. Continuous.
Okay. Let me come back to it. Percentage of blood leaving the heart. Is it interval data or ratio data? Percentage of blood leaving the heart at each contraction. We are saying that there are no 0 values. I'm saying from 14 to 72. So is this a interval data? And no, I don't know whether I'll get 0. Is it a interval data or a ratio data? See, this is where very important for you to understand when you do the data cleaning. Is it interval data or ratio data? Make a guess. Make an educated guess. Try to justify it. So Shanmugapriya says it is interval data. Why Shanmugapriya? You should justify it. Good. So in the chat window, Shanmugapriya says it is interval data, which is correct. But no, why don't you justify it?
As there is no true zero, sir. Whether if you
There is
have a ratio, it should be a true zero, right?
correct. There is no true zero. How will you say it is there is no true zero? If the value is zero, that means the person is dead, right? Here we are talking of if there is no percentage of blood leaving the heart, it means the person is dead. And we are not taking the data of dead people. We are trying to see whether a person will get an heart attack. Okay, blood in platelets. Again, the smallest value is 1,10,313 and the largest value is 3,71,302. So level of CPK and platelets in blood. Is it continuous data or discrete data? Can it be continuous data, discrete data? It looks like a discrete data, but you can consider it as a continuous data. I'll give the logic behind it. The range is almost 2 lakhs. 1,10,313 and 3,71,000. So no 2,60,000 is the range. When the range is extremely high, one small thing that we can really understand is the value 1,77,773, or if the value had been 1,77,774, there would have been no change at all. There would be no difference at all. Correct? You can look, you are going to eat rice. You got food. Now, how will you measure food? You can measure food either by cups. I can say I'll take half a cup of food, rice. I'll take 1 cup of rice. I'll take 1.5 cup of rice, right? Now, instead of that, I have a machine which counts the amount of rice. It tells, and then you can say I'll eat 1,235 pieces of rice. Or no, you might say 15,250 pieces of rice. If 4 perka ಜಾಸ್ತಿ இருந்தாலும் பரவாயில்லை கம்மியா இருந்தாலும் பரவாயில்லை, it does not make a difference. Am I right? So if you want to eat 15,000 rice pieces of rice, you can say 15,010 is also you can eat. 14,19,990 also you can eat, and still you will feel full. So here platelets can be considered as continuous data. Why am I emphasizing this? So that when I do the histogram analysis, I can form the bin accordingly. Okay. Level of serum creatinine in the blood. I see the smallest value is 0.5, the largest value is 1.6. What is this type of data? Is it continuous or categorical? Sorry, is it continuous or interval or ratio? Is there an interval between between the values? No, there is no interval. So it can be continuous. It can be treated as continuous data. But again, no, you can argue whether it is continuous, non-continuous. Then I have my serum sodium. Let me not get into that. One more interesting question, which is smoking. Smoking, the data is occasionally not a smoker, less than 5 cigarettes, more than 10 cigarettes, more than 5 cigarettes, but less than 10. What is this data? Is it ordinal, categorical, or interval? Is it ordinal, categorical, or interval? Somebody can tell me. What is the type of data? Ordinal, categorical, interval. Trinakarsu, Karpagapriya, Shanmagapriya. Anybody?
Sir, can you please repeat the question, sir, please?
Yeah, I asked a simple question. I have the data smoking. I had the data smoking, and smoking, is it, what is the type of data? Is it categorical data, whether it is interval data, whether it is ordinal data?
Second, we can make the categorical and also ordinal, sir. Categorical, smoker, non-smoker, like that.
Okay, excellent. Okay.
Maybe if you go for ordinal, like how you mentioned, like 5 years or 10 years, like that, or occasional.
Correct, correct. So this is already a ordinal data. If I want, I can always convert that into categorical data. Okay, I can always convert this into categorical data if I want. Okay, but as of now, I don't have a requirement. I'll stick on to ordinal data. Why? Because when we do some tests, we'll be forced to convert based on my algorithm. I am forced to convert some of the data. Okay, and when I'm doing that, it becomes extremely critical. Okay, so now you saw this data, you have started understanding how to see the data. Okay, I've used only about 1000 records or something, but you can use any amount of records. Now what I'll do is I'll go back to my presentation. So I'll go back to my presentation. Okay, now when we talk about the data, whatever I showed you has about 1000 records. Within that, I have taken multiple samples. Let me go to that slide directly. Okay, I've taken multiple samples. Please understand, let us say this was the heart disease data set. I've taken master contains all the records. All these records were obtained from 3 sources. Sources 1, source 2, and source 3. It could be Apollo Hospital Chennai, Apollo Hospital Telangana, Apollo Hospital New Delhi. As researchers, this is very important for researchers. You might get the data from multiple sources, because you do not have a lot of big data sets available for the research that you are carrying. In that case, you may be forced to create the data set yourself. You may have to take it from multiple sources and then try to create a master source. That is one. Second is, before running any of the algorithms, we always try to take a sample of it. This is master underscore A is a sample of master. Master underscore B is a sample of master. That means I am trying to say master underscore A contains 50 records. It contains only 50 records, whereas my master contains 1075 records. So I'm taking a sample from the master. I'm calling it as master A, master B, master C. Similarly, I'm having a source A, source B, source C. Okay, why am I doing that? As a researcher, one of the biggest challenge that you will face is getting compute power. Correct? So as a researcher, you'll face the problem of compute power. What do you mean by compute power? You will not get the resources. Okay, even though you might have in Anna University syllabus, you might be talking of having big data lab, or you're talking of a cloud lab where you have a Hadoop setup. But what is the resources you are using? You are using your regular processor. We may not even have a Xeon processor, or if some people colleges have servers like a Xeon server, you might have 2 Xeon servers. You create master slaves, you'll create multiple nodes, and then you start running it. But in real life, why am I using big data? Because I have millions and millions of records. The problem is non-deterministic. That means no, my computational time is not linear, it is non-linear. Okay, it may follow a polynomial time, it may follow a exponential time, I do not know. So the time complexity, order of n log n or order of n squared or whatever it is going to be a challenge. And with this challenge, you may not be able to use it in the college environment or with the hardware that you have. So one easy way to do that is to make samples. Get the samples, try to see whether the sample follows the original population. So whether it follows the original population. If it follows the original population, then you can very safely tell whatever algorithm you are trying to talk of. No, it can be a decision tree algorithm. How decision tree algorithms are used in big data analytics is what we'll see next. But whether decision tree algorithm will work or not work is what you need to check from the smaller data. Okay, you can see, it can be a trailer sort of thing where you see the results. If it is very encouraging, then you can try to take it at a bigger picture. Okay, so instead of 1000, I have taken only 5% of the data, which is 50. Looking at this data, can you looking at the various parameters, min val, max val, median, mean, median, modes, I've done it for only one component, which is age. I've measured the skewness, kurtosis, interquartile range, quartile 1, quartile 2, quartile 3. So quartile 2 is nothing but the median value. So whatever you see here, you'll see here. Can we look at this descriptive statistics between the masked source and the sample that you have selected? No, you might be doing something in image processing, which I'll run in the next subsequently today. We'll talk about image processing. The research papers might be talking about 1 lakh images, and they'll talk of using about massively parallel processing, whatever technique, Hadoop or whatever it is, Skype, Spark or whatever you want to use. But the challenge here is you do not have the resource. I can borrow resource. I can go to Amazon, and try to get the resource. But no, that will not give me the control that I want. In which case you would prefer using your own resource. And the resource is limited. That is one case where you can look at taking the samples. Once you take the sample, you check whether the descriptive statistics and the samples are almost the same. If they are almost the same, it's a very crude method to do. It's a very crude method to do because this is where you set your hypothesis, the null hypothesis and the alternate hypothesis. Okay, so we try to reject the null hypothesis in certain scenarios. We may try to accept the we try to reject the alternate hypothesis. Okay, so what is it? If I'm looking at a null hypothesis here, what I can say, there is no change between the population and the sample age will become the null hypothesis. What will be my alternate hypothesis? There is a change in the average values between the master and the population. Got it? Or there is no change in the age between the sample data and the master data and the population data, which is the null hypothesis. The alternate hypothesis will say there is a change. There is no change, null hypothesis. There is a change, alternate hypothesis. Within alternate hypothesis, I can give two types of this thing. There is a decrease in the average value, which is called as one-tailed solution, or there is an increase in the average value, again called as a one-tailed solution, or I can say there is a change in the value, then it becomes two-tailed solution. When I say two-tailed, what it means is I want to check whether my sample is from this region or from this region in the normal distribution. Okay, so this is the first part of your data analysis. So looking at this data, are you able to understand and say, is there any differences on the samples? Anything on this side are the samples. Is there any difference in the samples compared to the original data? There seems to be no difference, right? You do, no variance, you do see a little bit of difference, but you look from the mean and median. Since mean and median are close to each other, we can confidently say it is a normal distribution. If mean almost equals median, then we can, to a certain extent say it's median there. No, it's a normal distribution, but I have my skewness. Skewness is minus 0.2. That means what? Is it positively skewed or negatively skewed? I see everywhere the skewness is in the negative range. What does it mean? Selecting the algorithm will become easy. Here we see the skewness are all low. It is between -1 to +1, so I can take it as normal distribution. But when I see the value as -0.2, -0.12, what does it mean with respect to the age? Imagine if you are able to imagine half the battle is won. If you are able to understand data, then 25% of your research or your problem statement are sorted out.
It's outlier, sir.
Sorry?
Outlier, is it outlier?
No. What does skewness tell me?
It's a tilting of data, like
Correct, tilting of data. So I have a negative skewness. That is, I see more negative value. From this, what can you analyze? Age. You have age, and based on age, what is it you can analyze immediately? Negative skewness. That means I have more older people, correct? Which is in sync with our data. Our data definitely tells older people are more prone to heart attacks. So our system shows that there are more older people compared to younger people, because this is a age data. Are you able to analyze that? This will come out of practice. Practice பண்ணிக்கிட்டே இருந்தீங்கன்னா தான் வரும். Without knowing data, getting into data science is, or into big data, data science, artificial intelligence, machine learning, AIML, whatever fancy terms you use, is a waste. Will be an absolute waste. So you need to understand the data before getting into data, any sort of analysis, or else you are not going to succeed. Whether it is your research, whether you are trying to transition from your current job to a industry job, which again I am re-emphasizing, because I am seeing a lot of professors moving from teaching to research. No, not to research, to the industry. And I am being in the panel of interview panels of some of the companies. I can very confidently tell you, we look only at the basics, because technology is evolving fast. We look at only one character from you. One is the basics, the second is whether you can cross skill. When I say cross skilling, what it means is, today you might say, I know Python, I know pandas, I know matplotlib, okay, I know numpy, I know scipy, I know scikit. Where else, when you go for an interview, they'll ask you, do you know keras and tensorflow? You can confidently say, I don't know. But if you say I am good in numpy and pandas, so I can handle whatever, I can adapt to TensorFlow, then it is there. That is something which we consider in the interview. Okay, we know that you have not used TensorFlow, but we look at your cross skill capability. That means whether you are able to adapt from pandas numpy to TensorFlow, which is extremely easy. 2 hours work, 2 or 4 hours work. Okay. The second is, I would like to understand how much you have understood data. Many projects have gone wrong because the data has been wrongly used, which I am also investigating in the industry, and that is something which we find. We go back to the data, either the sample is poorly taken, or the data is analyzed wrongly, or the biggest challenge is the data is non-normal. The moment it is non-normal, I'm going to have a lot of challenges. Any observations in the data here, what I'm sharing? Any observations? No observations? Yeah, we don't know, we are able to categorically see that no, there is no difference in the sample and the population descriptive statistics. Now, we have the second challenge which you need to understand. The moment I talk about this data, I need to understand one more important component, which is, the location of the data. Okay, it is found using z-score. When I say location of data, you have a student in the class who has scored 30 marks. Can you tell what is the location of the student? Look at this from a slightly different scenario. The highest mark scored is 35. The highest mark scored is 35 out of 100. Lot of students have scored 32, 31, 32, 30. So where is the location of the data? The location is at it is almost equal to the maximum. That means the student has performed well compared to other students. Am I right? Alternatively, look at it from a different perspective. I have students who have scored 20, 30, and somebody has scored 90. Then the location is on the far left. The moment the location is in the far left, I can immediately take a call stating the student has scored very poorly. That is how you should be able to analyze the data. Now, let us say here what you're seeing is I'm seeing two parameters. One is age and the second is salary. If you look at the age and salary, what is the challenge I'm seeing here? The biggest challenge that I'm seeing is, one second. The biggest challenge I'm seeing is if I try to find a location, if I look at 20 to 60 and my age is 30 and my salary is 60,000, for a computer, these two values will look very large. These two values will look very large. 30 சின்னதா தெரியும் 60,000 பெருசா தெரியும். But actually பாத்தீங்கன்னா 30 is a average age, 60,000 again is a average salary. Or not 30 and 20,000 makes a lot of difference. So I want to convert this data such that it has a uniform range. It can be between -3 to +3. Typically, for that we use something called as z-score. Z-score is what is used to plot your normal distribution. The formula for the z-score is z equals x minus mu by sigma. Now here I ask you a simple question. Is this formula for a sample or for a is it for a sample or is it for a population? Is it for a sample or for a population? Give me 1 minute break. I'll get back to you shortly, but no, you can try doing the calculation. I've said the mean is 34.1, the standard deviation is 11.64. I got the z-score age. Try to understand, try to visualize what does a negative z-score indicate, what does a positive z-score indicate. Okay, I'll just join in a minute. Are you able to see? I have given the z-score information for the age and the this thing for the income. What is it you are able to understand? If I get a negative value, what does it mean? If I get a positive value, what does it mean? Anybody can guess about it? I have my normal. I can again plot a normal distribution. My mean. When will I get 0? When my data value and the mean value are the same, then my z-score will be 0. Correct. That means if I have a data point which is which is equal to the mu, then I can call it as x minus mu, means I can happily call it as this thing 0. So நெகட்டிவா வந்துச்சுன்னா என்ன அர்த்தம், பாசிட்டிவா வந்தா என்ன அர்த்தம்? ஒரு salary இருக்கு, you have a salary of all the teachers, the salary is not given but the z-score is given. How will you analyze it? Remember, I am talking of the salary of all the people in this group, teachers. I get some negative z-score salaries and positive z-score salaries. What does negative indicate? What does positive indicate? What does negative indicate? What does positive indicate? Look at it. I have my normal curve. In my normal curve, or no, I am plotting it. Let us say I'll just, okay. Let us take it here. I have this data. I have the mean value. The mean is 0. So if I get a negative value, the z-score will be plotted in this area. If it is getting plotted in this area, then I can very confidently tell that the person is getting a salary which is less than the average salary. Okay. So for an assistant professor, the starting pay might be 30,000 rupees. And if a college gives 28,000 rupees, then my z-score will be negative. Some college might be paying 33,000 rupees, in which case my z-score becomes positive. So z-score above the below the negative, below the mean value, you get a negative z-score. Anything greater than that, you get a positive z-score. Why z-score? Because it is extremely, it is extensively used in lot of algorithms. The moment you see minus 0.01, I can say it is almost equal to the mean value, because 0 is here, minus 0.01 is very close to it. So you see that the mean is 34. So 34 I've got it as, it is almost 34.1. Mean is 34.1. The age is 34. It is slightly lower than the mean. So I got a negative value. Got it? This is something which is extremely useful when you are trying to visualize your data and trying to take it to the next level. Okay. Here what I have done is, I have done a plot of the z-score. I have done a plot of the standard deviation. I have also done a plot of the percentile. So what is percentile? Somebody can tell? I'm talking about z-scores. We also talk about t-scores, extensively used, but no, I will stick on to standard deviation, percentile and z-scores. Anybody can tell what is percentile? Let us say I have the 10 marks of 10 students. I can put it in ascending order. Mark 1, 2, 3, 4, 5, 6, 10. And the 9th rank is called as the 90th percentile, which states that there are about 90% students who have scored lower marks than me. That is what your percentile talks about. Okay, so what I'll do right now is I'll try to jump to an example in Python, so that you can also try to understand. I think we have covered almost 1 hour 40 minutes. So no, your interest level will start coming down. I'll close this and let me get to an example. I'll show you the example and try to tell you how the data works and things like that. Okay, I'll first. So are you able to see my Python notebook? Are you able to see my Python notebook? Yes or no?
Yes, sir.
Thank you. So let us not worry about it. No, here if you see, I'm importing NumPy, I'm importing Pandas, SciPy, Matplotlib. Okay, you can all my this thing is, if you want to learn Python and do a lot of work in Python before moving to big data, because where in big data the underlying hardware changes, the underlying technology changes slightly, but the programming is going to sit on the Python framework. So I would always suggest, if you can master or if you can understand NumPy, Pandas, SciPy, Matplotlib, becomes much more easy for you to take it forward. And of course, you have sklearn also, which you can do. TensorFlow and Keras are other options that you can seriously think of. Matplotlib gives you very beautiful visualization. Okay, Pandas you can use it for handling the data. Okay, so what I'm trying to do here is I'll just first run this so that the libraries are all loaded. I go to the second group of code. So I'm giving the standard commands. So if by chance you get errors, if you get errors when you're running the code, especially that you take from the internet, read the error. Normally in the error, it will tell you some library is present, not present. Okay. So I want to load the data using Pandas, but the sample which I got in the internet might have loaded using some other tool which you are not comfortable. Absolutely not a problem. What you need to do is you need to understand the moment if that library is not in your system, you run this and run the next command whichever uses that library. Let us say you have not installed Pandas in your system. If Pandas is not installed, what will happen is you will not be able to read the data. Okay, so what I'm trying to do here is I'm giving some name to the data. It is normal, abnormal. That's all. There are two records, there are two variables in my data, and I'm calling it as normal and abnormal. I will explain more about the data when in the second session when we talk extensively with respect to how a entire project works. Okay, so the next thing that I'm trying to do is I'm reading the data using the Pandas library. So I'm using the command read_csv. Okay, I am reading the data. I also give what is the name of the columns or the variable names. I'm telling the variable names are normal and abnormal. I run that. So now my data is loaded. Till now you are not able to see anything. Now, what I want to do is I will want to see some of the data. So I will use the word head. When I say head and give 10, I'll be able to see the first 10 records, including the header. So my header is normal, abnormal. I'm able to see the first 9 records. If I want to see the first 15 records, I can give it a 15. I can rerun it. I'll be able to see 15 records, 1 to 14 along with the header. I can also now keep it empty. I can keep it empty. I'll see only 5 records being shown. Okay. Now I can use a very simple command called a description to see the entire data. I can use a very simple window. I can use a very simple command to see the entire data by using the description. But as I told you, your Python or many of the libraries in Python do not understand the type of data. You give the data, it will process it. So what I am going to do is, I am trying to take up each record. I can take up each record. Okay, I am giving a variable name. I am using the round command. What does the round command do? Anybody has an idea what the round command does? Round is a command to round off the value to the number of decimal points stated. Here I've told, if you see here, I'm seeing the data as 34.481230. But when I'm measuring the mean, I want the data only for the last, only 2 digits to be shown, the 2 decimal after the decimal point. I'm using some variable names. You will understand this more in the second session. X-ray before processing normal mean. I'm using something called as normal data and abnormal data. So I want to find the normal of this. I want to find the mean of the data here. Okay. So I'm using X-ray before processing, which is the file, which is the container having my data. And within that, I want to select the column called as normal. So I'm using square bracket. Then I want to use the library mean. Okay, library or function, however you want to take it, whichever programming language you are comfortable with. Mean is a function. Okay, every time you see a Python piece of code with small brackets, you can very safely say that it is a function. So I'm finding the mean, I'm finding the median, I'm finding the standard deviation, I'm finding the quantile. If I look here at 0.01, what does it mean? I am saying the quantile is 0.01. What does it mean? It means it is the first quantile. Okay, I'll change that to 0.25 so that I get my 25th quantile. I'll change this to 75th quantile. Okay, so that's why I'm calling it as Q25, Q75. Then I'm measuring the skewness. I'm measuring the skewness for the normal variable and the abnormal variable. I'm measuring the kurtosis. I'm measuring the min and max value. So let me run this. Whenever you run it, it gets executed and the variables are stored in the, the outcome is stored in the variable that we have given. I want to see the data. I have written it in a very simple format so that people without knowledge of Python can still understand it. What I'm trying to highlight is Python is an extremely easy language to learn. There is no challenges learning Python. I get a lot of people who are good in Python because Python is something which you can learn in a couple of days. But when it comes to hiring, my challenge is they don't understand data. That is why I stress so much on data. I will print the data and show it to you. I am running it. Have a look at this. Okay. So next what I try to do is I want to do a histogram and see what it is there. So I'm creating a bin list. I'm just creating a bin list. Why up to 3200? Because I see the maximum value is 3320. The minimum value is 0. So I created a bin where I'm talking 0 to 100, 101 to 200, 201 to 300. That is how my bin list comes in. I'm talking of, I'm creating 2 variables, A and B, and I'm just reading only the normal and abnormal data. I use my plot command from matplotlib. I'm giving a very simple query to it. I want the histogram. So I'm telling the name of the bin list is bin list 1. It is bin list 1. And I want to find the histogram. The histogram is actually using the hist command. So I give my variable name. I want to find the histogram of the variable name normal. Histogram and I've given the title histogram of result. I'm giving the bin list will be the X tick and Y tick, the marking on the X and the Y axis. Then I'm also giving the label, Y label I'm stating should be the histogram values. I use the PLT show command. Okay, if you are familiar with MATLAB, you would use the plot command. Let me run this and see the histogram. Okay. So can you identify anything in this histogram? Are you able to find any abnormality? See, when you see this histogram, you should be able to read it. I'm not able to use my pen, but if you are able to see the pointer, I am trying to draw a graph. It is positively skewed or negatively skewed. Seeing this graph, I can say it is highly positively skewed. So what is the skewness that I'm seeing? I'm seeing the skewness of 5.54 and 12.82. What did I tell you? If the data is in the range of, if the skewness is in the range of -1 to +1, then it is not skewed and it is a normal distribution. Here we have a non-normal distribution. So post lunch, what we'll do is I'll take up this non-normal distribution. In a very simple term, I'll convert that into a normal distribution. Then we'll also give it to a classification algorithm in in Python to see the outcome. Fair enough. So we can connect at about 2 o'clock. So Geeta madam, can I stop? Geeta madam or somebody from Excel?
Sir.
Yeah. So shall I stop now and start again at 2 o'clock?
Okay, sir.
Okay.
Sure.
Thank you all. So now 2 o'clock, I'll talk about the COVID data set, which is from one of the highest indexed SCI journal, where a lot of Nobel laureates publish their work. It is from Nature. I have taken the data. I'll show you the paper. And we'll do an analysis. So this will be very useful for people who are doing research, and it will also give you a holistic view that how a real-time data is working. Whatever code I showed you was on Python code was on that data only. So I'm just trying to show that it can be replicated and it is not impossible. Okay, thank you all. I'll again come back to you by 2 o'clock. Thank you, madam. Thank you, Geeta madam.
Okay, sir.
Thank you. Bye.
We'll start the session at 2 o'clock, sir.
Thank you. You can give
Okay.
instructions. Thank you.
Thank you, participants. We will start the afternoon session at 2 o'clock. Kindly join. Thank you.